হ্যালো ক্লিন্টন,
হ্যালো ম্যাডাম।
ভালো আছো?
এই তো ম্যাডাম, ভালো। আপনি ভালো আছেন?
হ্যাঁ, আমাদের এখানে জুলাই 4 হলো। তো আজকে আর কি এই উইকেন্ডে ছুটি। তো
আজ-
হ্যাঁ, আমি আবার আরেকটা শহরে আসছি, আজকে রাত্রে ফেরত যাব। কেমন হচ্ছে ক্লাস? তোমাদের কোনো ফিডব্যাক পাওয়া গেল?
হ্যাঁ, এমনি ভালো হয়েছে মেয়েদের।
আচ্ছা,
তো মেয়েদের কাছ থেকে তো মোটামুটি এমনি পাওয়া যাচ্ছে feedback।
আচ্ছা, তাহলে
আর
হ্যাঁ। হ্যাঁ,
মানে ফ্রাইডে যেটা ছিল ওটা আমি ভুলে গেছিলাম, মানে একটু। এই জন্য আমি ওই দিনটা পরে লেটে জয়েন করি
হ্যাঁ,
গত
বাট
ক্লাসে।
এনিওয়ে জয়েন করছো, এটাই ইম্পর্টেন্ট। হ্যাঁ।
আজকে সিস্টাররা থাকবে।
ও আচ্ছা।
সিস্টার কনিকা থাকবে, সিস্টার মেনে থাকবে।
আচ্ছা, ঠিক আছে। আমি তোমাকে co-organizer করে দিই যাতে করে ইউ ক্যান
ওকে।
let people in. Hello, hello everybody. Welcome. Um, আমরা আজকে শুরু করব with our third session. So let me share my screen. Let's see. Okay. So আমরা আজকে শুরু করছি আমাদের AI Education and Leadership Program Part 1 Session 3 এবং this is exclusively prepared for Holy Cross College Class 12 students and faculty. আমি ডক্টর নুসরাত রাব্বি। আমাদের এটা থার্ড ক্লাস, এটা ইউটিউবেও স্ট্রিমড হচ্ছে। And you're welcome to participate by chatting in the WhatsApp group, or you can also put questions in the Zoom chat. So I can see. I see that Sister Costa has joined, Sister Kalpana has joined, and Ms. Sarkar has joined. So thank you for joining, sisters, as well as Clinton and as well as the students. আমাদের এখানে জুলাই 4th সেলিব্রেটেড হলো গতকাল, আজকে জুলাই 5th, সো আই এম আউট অফ টাউন। তো আফটার দিস লেকচার, টুডে সানডে, আমাদের এখানে সানডে হলিডে, and then I'll be heading back home to New York after this lecture. So everybody please go on mute, and so that we can carry on. আজকের লার্নিং অবজেক্টিভ হলো, সরি ক্লিন্টন, ডিড ইউ হ্যাভ সামথিং টু সে?
না ম্যাডাম, বলেন।
আচ্ছা, ঠিক আছে। আমাদের তিনটা অবজেক্টিভ আছে আজকে। অবজেক্টিভ 1 হলো এক্সপ্লেইন হোয়াট মাল্টিমোডাল এআই ইজ। মাল্টিমোডাল এআই এটা কি? We have to be able to explain that, describe how it integrates with data, তারপরে text, image, video, three-dimensional animations, scientific data.
Nusrat.
Yes. Hello. Sister, did you want to say something? Okay, then objective 2 is the recognize when AI is performing reasoning. Reasoning আমরা কিন্তু কতবার আমরা বলেছি about querying the AI, like Hamlet, of Shakespeare, Hamlet the character. But now, on top of querying, we have to see how AI performs reasoning, meaning evaluate evidence, compare alternatives, make inference, হচ্ছে decision, and justify conclusion. এই জিনিসগুলো কিন্তু একটা ইনভেস্টিগেশন, যে কোনো সায়েন্টিফিক, সোশ্যাল সায়েন্স বা লিটারেচার বা আর্ট, এগুলো কিন্তু করতে হয়। ইউ হ্যাভ টু ইভ্যালুয়েট দ্য এভিডেন্স, compare the alternatives, make inference, and justify conclusion. Actually, Hamlet does that in Shakespeare. But last time we talked more about the importance and the way to query AI. Today we move to a new level called reasoning. Objective 3 হচ্ছে আজকের, we apply problem decomposition. একটা প্রবলেম, একটা বড় প্রবলেম, একটা বড় প্রবলেম ধরো you want to give to AI, সেটা ডিকম্পোজ করতে হবে। So how do we break it down in a complex task into smaller logical steps before we ask AI for help? That also helps AI. It's kind of a human steered help for AI. এই তিনটা হচ্ছে আমাদের objective for this session. So let's talk about multimodal AI. Multimodal AI হচ্ছে modern AI understands and generates much more than text. আমি I would say যে আমার use still with AI, mostly text. Today we learn about how multimodal AI, what it is and why it matters. So AI that works across multiple forms of information, যেমন text, image, audio, video, and 3D representation. And humans naturally integrate modalities. তাই না? আমরা যেমন during the day daily life we look at a movie, we get out of the street, out of the way of a truck before we cross the street. তারপরে if a car honks, we hear it, the sound. So everything's happening in 3D and engaging other senses. We're looking at video. Our brain is understanding multimodal information. And AI does too. And as time goes by, AI is getting better and better in integrating multimodal information. So modern AI understands and generates more than text. And we have to explain that AI that works across multiple forms of information. Okay, so I've already gone through that. So this is interesting because let me introduce Holland. Holland হচ্ছে আমার actual real life dog. এই যে আমার পাশে বসে আছে. So Hollander, I took a picture. I took just a picture from my phone and I uploaded it to AI and I said, put Holland in a movie poster. And this is what AI generated on the left, based on a true friendship that changed everything. Holland isn't just a pet, he's family. None of these I told AI. Holland, a tale of, look at the spelling of tale, of loyalty, love, and adventure. It's beautiful, isn't it? And then I said, take Holland's picture and generate a children's story. And it did it on the right. Holland's big day. Holland is saying, today is going to be awesome. And তারপরে number one হচ্ছে Holland meets Sammy the squirrel, and then Holland meets a bird and helps her, and then Holland finds a tennis ball and plays with a boy in the park, and so he has a very busy day. All of this was generated without any prompting from me. Just a picture, just a picture of Holland. So behind this, let's take it apart. Behind multimodal AI is something called vision language model, okay, called VLMs. Just like we were talking about large language models, there's really some behind this is called a vision language model, VLM. This is the actual name for the system, not just an LLM. So please mute yourself. I think I can hear some of you. Please mute yourself. Let me see if I can. Yeah. So so what vision language models do is it connects computer vision with natural language. এখন ছবি আর ল্যাঙ্গুয়েজ টুগেদার করছে AI. So it can simultaneously see pixels মানে ছোট ছোট ডট গুলা ছবির, and also read text prompts. So then what it does, you will not be surprised to know, they do something called visual embedding. First time we talked about embedding vectors. There's also visual by image embedding. So when you upload your dog's photo, AI should just save করে না. AI translates the pixels on the grid of the math coordinates. So it translates the pixels into a math coordinate of a grid of pixels. This map captures the visual context, just like language context. This map captures the visual context. the specific distance between your dog's eyes, the floppy ears of Holland, the shape of the snout, and AI retains the dog's unique identity. So, how would this be like a text context? Jamon, we talked about it last time. If you give it a question, it'll remember that you're a high school student, you are studying for an exam. That is the textual context. আর এখানে after the embedding, AI তৈরি করে from the vector map or a grid of math coordinates, which is the image embedding. It creates a visual context, and that becomes Holland to it, Holland's unique identity. Then it uses another concept. So there's the third. First is the visual language model. So it understands pictures because it takes all the pixels and it understands the picture. That's a vision language model, and versus large language model. They are one and the same, but vision capable. Second হচ্ছে image embedding, and third হচ্ছে cross attention, style transfer. This is the bridge mechanism. So when I say movie poster or cartoon storybook, it directly lays the it layers the text prompt over the mathematical map of the eye and the ear. So it uses cross attention to force the output pixels to keep my dog's specific face shape while completely swapping the artistic textures, lighting, and art style. So, for example, if we go here, you can see this was the picture I actually uploaded. This is the exact face he was actually playing. I didn't have a sun shining in the background, and this garden, this lawn was not in the picture. He was laying on the grass. But look, it is able to preserve the image embedding here, number one. And this is a different posture for Holland. He's standing up and he is looking at a squirrel. So this is different. And here on the bottom row, he's sleeping. I didn't feed that picture. So that is the generative quality. So it takes this image embedding, which becomes the visual context, and then it uses cross attention to transfer this embedding into this new image that goes with this text. A textগুলো ওর saved ছিল already because it comes with this children's story. So it uses cross attention to force the output pixels to keep your dog's specific face shape while completely swapping the artistic textures, lighting, and style. So we could say, well, how do we recognize the identity across style? How does AI turn one photo of Holland into both a movie poster and a cartoon while keeping him recognizable? Now, even 2 years ago, it was not doing it or not doing it properly. If you remember, for those of you who used it, the AI in 2024 or so, it's gotten so much better. So the model separates identity from style, what it is and how it looks, by using two distinct mathematical shapes inside the embedded space. যেখানে আমরা বলছিলাম embedded space, right? Like in the first lecture, we said the capital of Bangladesh is you know, so then, it'll has some embedded space of Bangladesh and cities already, and it's not going to fetch London or Lisbon as the capital because it's in another space. So um, in this space, there are two distinct maps. One is called fixed geometry. এটা হচ্ছে identity map, fixed geometry. আমাদের সম্বন্ধেও AI has a fixed geometry, and then there are some variable ones, like what we do every day. The fixed geometry is the exact ratio between Holland's eyes. So these are the kinds of things that make a living organism like a dog unique. আমাদের তাই, the structural downward angle of the floppy ears and the exact shape of the snout, which is this part, relative to the forehead. So this one relative to the forehead. So these are not all of the fixed geometry features, but these are the ones that are preserved from the image. So one, it instantly recognizes that this is a dog, and then it stores the fixed geometry for this particular dog, Holland. Now, the style layer or the swappable textures are photorealistic film grain versus cartoon ink, cinematic shadows, তারপরে, a rising sun, flat meadow, digital paints, and the movie has a dramatic movie set lighting versus the bright children book background. So these are already learned. For example, these are already learned from studying many, many, many movie posters. And the children's light, breezy park day storybook is also AI knows from having studied many, many children's story illustrations, for example. So the cross attention bridge is the main leap. I know. Once you store it in the visual embedded image embedded space, and you have your text instructions for park and movie poster, then you have to use the attention bridge. So your text prompt guides the style layer, the second layer. The identity map forces the output pixels to lock onto Holland's unique facial structures. So the takeaway is that to the AI, Holland is not defined by his fur color or lighting. Has a permanent, unique mathematical signature that can be painted onto any artistic universe or palette. Okay, so it's quite ingenious. You can see that actually, I mean, the entire basis of artificial intelligence is mathematics. We don't need to know all the high math, but we can truly appreciate how math is being used to represent knowledge of in any domain. And in fact, that is true of the physical universe as well. So let's think about another example. Let's say you're going into now you can say, well, how am I going to use multimodal AI? In other words, why are you talking about it? Because is going to become part of your education as you go into the universities. You are going to go beyond text AI, and you'll be doing multimodal AI to do your studies in the future. So one example is, it's kind of a high-end example, but let's walk through it anyway. It's in molecular biology called protein folding. So this has baffled biologists for a long time. They had to call in physicists and do many days and weeks and months of programming to see how proteins fold together inside the cell of the human body, millions of cells in the human body. So now, though, what we can do quite easily is feed a text sequence of amino acid letters, okay, like arginine, leucine, and so on, into the system. And the AI would predict how it's going to fold the protein, okay, because in real life in the body it folds. It's not just a static necklace of amino acids, it folds. And the folding actually, the shape determines what it's going to do. So the AI model skips the physics and instantly outputs a highly accurate 3D protein structure. So when we look at this demonstration right now, which was generated using AI, we see that how changing a single beat in the sequence can cause the entire structure to reshape itself to fight or trigger a disease. This is, so if we go here, let's see. So here is a bead of amino acids. So the cells have genes, they code for DNA, for protein instructions. And these are the acids that make up a protein. And there's many, many, many such proteins, right? So if I say generate a random protein, okay, that's fine. And here's how this is AI now, it's going to work like this, you see. This shaking is all the hydrophobic, in other words, much kind of amino acids, they don't like water, so they're kind of in the inside, they're hiding, and the ones that are not afraid of the water are on the outside. And why it's important to study this is viruses organize themselves like this too. And if you can find out how the virus is folding, then you can build a medicine, because this is how it locks into the human cells, say. You could buy medicine to neutralize this. So if we can even take one of these and make it actually, and it will organize itself in a different way now. If you can change the structure and see what happens. So now, so it's in real life, it's doing this. This is what it would do in real life. And so it requires the merging of math, physics, and biology to generate this structure, for example. So now it is very easy to do it. This is a good website for that. Also, MIT has DeepSeek. So they have actual, anywhere in the body, you can go and see what the proteins are, how they fold, and it's very important in studying disease and biology and other organisms. So let me make it full screen again. So we just saw that the genes inside our cells contain the instructions for proteins. The instructions are amino acids, the bead together. It's like a bead in the long chain, and the movement is inside the cell. This chain is constantly shaking, curling, and folding into a 3D machine. And real proteins have thousands of these beads. So taking together regular computer years to simulate step by step, and hundreds of people would do this. And now the AI can skip the physics and all the compute time and analyze the sequence and instantly predict the final 3D shape of the beads. So it helps a lot in finding cures, in understanding biology, in understanding virus protein sequences, and so on. So last line here is viruses use their 3D shapes to lock onto healthy cells. So AI lets us look at these shapes instantly so we can build custom drugs to block them. So another example of where you will use multimodal AI in college and university is film and media. So suppose you would be able to upload a basic 2D storyboard sketch. Okay, for example, you can have your own sketch on a piece of paper, or you might have multiple sketches. Like that children's story, you can have multiple sketch of different scenes in progression, and you could pair it with a written script and describe camera angles and lighting. And the AI has a video generator, not the ordinary chat GPT, but there are programs, AI programs that will actually generate the cinema. It will merge the visual layout with your text instructions and output the cinema. So the big point is the AI is your virtual director, and it can translate raw static framing and descriptive text into real-time fluid movie with camera, motion, and lighting. That's another example of what you might do. So now I do want to talk about the idea of human judgment in a multimodal AI world. So let's first talk about this point called the AI illusion. So multimodal architectures, as we saw it today, use representation learning to map text prompts and image embedding across a shared embedded space. So in this embedded space, there's text, there's images, but what I didn't show you, there's also audio and video and music and all forms of modes of information. They reside in a shared embedded space from consuming vast amounts of information from the world, a vision language model gulate, and it uses representation learning. So this first sentence that I'm pointing to, these concepts should be familiar to you now. Embedded space and embedding, representation learning, and multimodal architecture. Okay, so this is how the multimodal architectures work. So not only does it have information, but the embedded space and representation learning means they have an interrelationship, like a knowledge graph of how things are interconnected with each other. So a tiger is not going to look like a dog, for example, and vice versa. ঠিক আছে? So anyway, this representation learning is what lets the AI turn one photo of my dog into a cinematic movie poster or a storybook cartoon. The hidden engine. These creations rely on what is called a diffusion model. Diffusion model is like the AI starts with a canvas of pure random noise, static noise, like like in the old days, if you have a television screen with its completely staticky and granular and grainy, and there's no understandable images, it's just flickering. That's what it starts with. And it uses cross attention to guide the cleanup process. It's a trick, actually. Starts with this pure random noise bitmap, and then cleverly cleans up the pixels, finally producing a sharp styled image out of the mathematical chaos. এই জিনিসটা করতে পারে from its embedded space and representation learning. It already knows about Holland and what he looks like and why I want a storybook, but then it starts with a um, random noise screen, and then successively tunes every pixel into the final image coming out, for example, like a storybook for Holland. So that's the hidden engine behind generating a new image, is called a diffusion model. So the 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 main thing I want you to understand here is the architecture relies strictly again on statistical probability and auto-regressive next token prediction. In other words, it will say, okay, what is it going to look like under a storytelling context, right? There's many ways it can manipulate this random noise screen, but it uses statistical probability models to do the next best pixel manipulation. So at the end, it's coming up looking like Holland lying in a park playing with a child. So when I say critical flaw, I mean it lacks physical or logical comprehension, meaning it can confidently cause hallucinations that look flawless but are actually factually or structurally incorrect. In other words, it knows about a storybook, it knows about the scenes, it knows about Holland and its picture, but it will create, for example, Holland sitting in White House and shaking the president's paws. So obviously, these are hallucinations. It can also invent things that look flawless, that wouldn't be right, and also they're factually wrong. But it could also be structurally incorrect. In other words, if I put a picture of Holland with a um, some other physical characteristic that's impossible for him to have, then it will propagate that structurally incorrect thing with that image. So main point is that it lacks comprehension. It doesn't really understand the way a human does. I produced some images that made sense to you, but I didn't understand that image made sense and why it made sense. And uh, you know, um, yeah. So that's the what I wanted to say. So the wow versus the truth. The diffusion model can generate a stunning movie poster that breaks real world physics, while a biological transformer যেটা আমরা দেখলাম can predict a beautiful 3D protein. But the point is, you can also make a protein that is chemically toxic. You can also come up with a nice folded protein that won't work in the lab. So it's not AI's fault. It's just that it does amazing things, but your judgment is what is needed to see if it's going to be useful, if it is false, if it is going, are you using it to do some harm, like producing chemically toxic folded proteins? So the human imperative here is that while prompt engineering steers the generation inside this latent space, it are a mathematical construct, latent space. We steer it, and we even built AI to be able to assist us in such amazing ways. And then we prompt it through prompt engineering to this generation of new material inside that latent space. But the human is the ultimate editor. Only human judgment can audit the output for scientific accuracy or creative output on real world truth. For example, if you take if you take a great song of, I don't know, let's say Sabina Yasmin, and you put it into with a video and you say that you are singing it, AI can generate that. But you have to use judgment. Is that right? Can you pass that on as your own voice or your own song? Right? So that's something, that never goes away. And it's needed, especially now, as our creative and generative abilities have expanded like 100-fold, 1,000-fold, and more as AI improves itself. So AI is becoming multimodal, and future professionals like you will work with all these different modes of information. And the future of AI has extended far more than chat. For example, the weather crunching, when the earthquake will happen, when floods will happen, those things needed massive computes because there was so much information. And with AI, it's much easier, faster to do that modeling now. That's all multimodal. So the other thing I wanted to talk about today is the reasoning. So AI can generate beautifully fluent text, but fluency is not the same as logical truth. Learning objective today is recognized when AI is simply predicting words, meaning next token, like the cat sat. What is the third word? It'll predict on. Cat sat on. It's like that. Is it predicting versus is it actively executing multi-step problem solving? The modern reality is the future of AI belongs to those who don't just ask for answers, but who know how to audit and test the AI's logical steps. So, what is reasoning? The reasoning is, in a very simple way, reasoning is a structured step-by-step process that connects verified input to a sound conclusion. Okay? If those of you who do math and who are going to do math in the university will know that you have to build up evidence to get to a proof. So the pillars of logic are reasoning requires an agent, an AI agent, to actively analyze parameters of the model. Why does this follow? What follows what? I am hungry. And then what follows that? I should get lunch. I should, what else would follow that? What are the logic of this? There's also field of logic, right? Which stands in between philosophy and math. And what are the underlying assumptions? What evidence is missing? So the difference is the information retrieval simply repeats a memorized act. In fact, when we just had Google, we could just retrieve. It would give us many, 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 many hits, usually ranked by probability, right? You didn't have to hit on the first search hit. You could have gone on to the second page or third page and hit. AI does much more than retrieval, right? It does reasoning. So it evaluates how competing facts interact to solve an entirely new problem, right? Again, what I'm talking a lot about what AI can do, but it's actually what we can do as well. And we talked about that the value of everything I say is when that value gets transferred over to you, not it staying just with AI. So reasoning evaluates how competing facts interact to solve an entirely new problem. Generation versus reasoning. Generation, I'd say, token prediction. We talked about it. The AI calculates single more statistically probable word to output next. It focuses entirely on linguistic fluency and also on the huge amounts of data from the world it has trained on. And for many interactions, that's good enough. It makes things sound plausible. If I say, after this lecture, I have to take a trip back to New York, it'll probably predict something like, yes, you should get on the road so that the traffic doesn't delay you. This is generation, token prediction. Reasoning হচ্ছে compute time logic, meaning at the time that you're talking about it, it has to do some computation. The AI deliberately weighs constraints, maps out intermediate problem-solving paths, and tests alternative solutions before answering. That's reasoning. So one analogy হচ্ছে যেমন generation is like a game show contestant blurting out a rapid response from memory. Reasoning is like a student sitting down in Holy Cross field with a scratch pad and sketching out a math proof step by step, or sketching out an artwork, page by page. That's reasoning and creativity. not just retrieval. So the 2023 থেকে আজ পর্যন্ত 2026, there's been a big shift. The 2023 old way, early models relied entirely on a single forward pass. The moment you hit enter, the AI immediately spat out a word, linearly without a way to plan ahead or fix its own errors. That's how 2023 it used to be. 2026, today, it's a modern way. Modern models utilize inference time compute or test time computation. As we are asking it, it will use that actual compute somewhere in the world on a cloud server. It will use computational engines, CPUs, to do computation to answer complex questions. These are intentionally designed to pause and think behind the scenes. There's also, I'll give you a brief flavor of something called hidden chain of thought, COT. AI generates thousands of hidden tokens to test logical branches of a tree, of a logic tree. It catches its own math mistakes and self-correct before showing any visible text on your screen. So inside, it is now coded to use something called a hidden chain of thought. আমরা human beings, we also have chains of thought. এটা এটা করলে এটা হবে, এটা করতে পারবো না because I have to get there by 3, I have to do this. We are also executing chain of thought in our brain. Recognizing reasoning tasks. Comparative analysis, forcing the model to actively weigh two competing scientific hypotheses rather than just defining them. You could do this. It will engage in reasoning. Okay. A doctor says this, another doctor says this. Compare and contrast. So it'll do a comparative analysis. Root cause diagnosis. Give the AI conflicting system symptoms to find a hidden structural or mechanical failure. For those of you who write computer code, you can give it a program and ask it to find where it's failing. It's called root cause diagnosis. The other example is constraint optimization. Demand a final recommendation that must balance a fixed real-world budget against complex laws of physics. We'll see an example of this. So these are far, far from information retrieval and token prediction. A reasoning example, the core problem. We ask AI to determine which renewable energy source best fits a specific small island nation, maybe Tahiti. The weak approach would be, what is the best renewable energy source for an island? The AI will use pure generation to instantly spit out a generic essay praising solar power. They could do this, they could do that, they could do that. I can say, what is the best renewable energy source? And I'll get a bunch of answers right now. But when I say what is because it most likely will be US centric. But when I say what is the best renewable energy source for Bangladesh, then it's going to do more thinking. It's still going to be weak because it'll write another essay that is a bit more specific. The deeper approach could be analyze the energy grid for an island with limited land mass, high cloud cover, and constant ocean currents. Compare solar versus tidal power, then it's really got to get to work. The activation difference. Prompt B shuts down lazy word predictions. It forces model to use inference time compute to balance geographic restrictions and evaluate actual engineering trade-offs. Testing reasoning with prompts. Avoid memory recall. Simple fact retrieval questions only. Test an AI's data index, context, and token prediction capability, not its intelligence. You can introduce friction. Break standard internet patterns by adding constraints. Design an electric car charger, but do not use copper wiring. Force method over conclusion. Explicitly command the AI to do things a certain way. Separate its assumptions, list competing alternatives, and justify step-by-step calculation out loud. So it is forced to show you its tree of thought. First of all, do it and then show it what it did. So reasoning in college, feeding an AI in an amino acid sequence to instantly map out complex 3D protein structure and predict mutations. Humanities, upload two conflicting historical records, let's say, of the Mughal Empire, two conflicting records of a king or a queen, and force the AI to isolate hidden structural biases or logical fallacies in either or both. Engineering, task the AI to find critical failure points with blueprints or custom code programming. You'll be doing this. The human verdict, the logical fragility, because AI models run on mathematical probabilities rather than conscious human comprehensions, a slight change in prompt wording can derail the logic tree. Fluent fallacies, because reasoning models still use fluent text generation to explain their step, you can still be fooled. AI can output an incredibly confident explanation built on fake premise. The human auditor, that's you. You have to audit. AI handles the brutal computational heavy lifting, but it's successful only when human judgment can verify the prediction aligns with actual physical reality, ethics, and truth. And that's the punchline. So fluency is not truth. Never mistake an articulate, polite AI response for a verified, logically sound conclusion. Actually, this is not that much different from most people who speak to you. Expose the homework. Always engineer your prompts to force AI to display its homework. Where's the intermediate steps, calculation, branch, and assumption? Critical habit. Just as Hamlet refused to blindly trust the ghost's word, your uncle killed your father, intelligent AI users must always evaluate the evidence before accepting a conclusion. Last but not the least, we want to talk about problem decomposition. Too many context window overload. Throwing a multi-part assignment at an AI all at once will flood its immediate attention map, which is a matrix. The autoregressive word prediction loop degrades. This is its key tool, causing the AI to skip constraints or invent facts, also known as hallucination. Giving the AI too much to compute simultaneously dilutes the quality of its mathematical path of reasoning. What we have to do is do a human steered pipeline. It's a tool Human-steered pipeline is nothing but a tool for problem decomposition. You're the manager. Manage an AI by breaking a single large objective into individual conversational turns. You prompt the AI to solve part A first, inspect its work, and then combine it, ask it to do part B using that verified output from part A. The shift, human behaves like a project manager, human in the loop, HITL, guiding the machine through a strict quality control pipeline. The pipeline works like this: error prevention. Even AI makes a logic error in step one, it will build subsequent steps on top of that error. Human audit. Force the AI to output one phase that allows you to catch and fix mistakes before proceeding to the next phase. Otherwise, it will snowball. Anchor the math. Once you approve a step, words are locked permanently into the conversation context, and it'll force the AI to be accurate on the next turn of the problem solving. Example, a biology research, write a comprehensive study guide about CRISPR mutations. It's going to get into token generation, and if that's what you want, that's fine. But you can steer it. Turn one. Prompt it to build a structured outline of mutation categories. What are the mutation categories out there? It'll tell you. Then you say, generate real-world analogies for CRISPR for category 2. So turn 3, direct draft university exam question based on the previous 2 answers. So you're breaking it down, making a pipeline. So the summary is: think before prompting, break problem into pieces, use AI to assist each step rather than solve everything at once. Structure produces better outcomes. So our module summary today is models map text and visual and audio context into a shared embedded space, allowing us to translate and concepts across different modalities, like storybook versus movie poster. And these concepts are multimodal, not just text, but protein structures, ion structures, physical object representations, images, and so on. AI reasoning is modern models use inference time compute to pause and evaluate logic, but their reasoning paths remain fragile and require human auditing. Chain of thought. Make it reason and evaluate the logic. Give it friction, give it alternative hypothesis, audit the answer. Last, unlock the true accuracies, break your complex task into structured step-by-step turn. Think like a scientist, question like Hamlet. Never let the machine outsmart you out, and never let the machine outsource your independent knowledge and judge. Use it to get more knowledgeable. Let's do a knowledge check. Everybody, please answer in the chat. Multimodal AI. An AI model creates 2 different artistic versions of the same dog photo while keeping this dog recognizable. How does the architecture achieve this? 1, It searches the internet for similar looking dog breeds and copy their pixels for different context. B, it separates the fixed geometry map from the swappable style layer within the embedded space. C, it edits the original photo directly using basic color filters. D, it guesses the text letters of the prompt first, then deletes the original photo entirely. The answer is B. Yes, many people are answering B. Thank you. Now, the second question is, how do modern 2026 reasoning models differ from older text generators when handling a complex logic problems? A, they immediately generate the final answer to save computational power. B, they skip next token prediction entirely and operate without using training data sets. C, they allocate inference time compute to pause, evaluate internal logic paths, and self-correct behind the scenes. D, they rely on human user to calculate the math equations for them in real time. Answer, anybody? Everybody's going with C. I think I'm going to go with C too. Thank you. Last but not the least, why is it structurally better to run a human-steered pipeline, breaking things into small parts instead of submitting one massive multi-part prompt to an AI? A, allows you to audit each milestone and stop logic errors from snowballing across the conversation context. B, it teaches the AI how to think like a human. C, it bypasses the context window so AI does not have to read your text. D, it forces the model to use less inference time, making the answer less accurate but much faster. Answers, please. A, A. Correct. The answer is A. And so, with that, I will, okay. So now, let me see here. Okay. I am now looking for my, anything else that we can, any questions? Okay, so let me see. I'm actually not finding the, so if there are no more questions, I think we can definitely conclude our session today. I am unable to see the, oh, no, I think I can see it. I'm actually trying to get back my screen control. Stop share. There we go. There is a question. Let me take that question. আমি কিভাবে মেটাকগনিশন ডেভেলপ করতে পারি যাতে বর্তমান ইন্টারনেট যুগে যখন আমরা বাইরে থেকে প্রচুর তথ্য পাই আমার চিন্তার স্বাধীনতা বজায় থাকে এবং আমি নিজের চিন্তার গতি ও প্রক্রিয়া সচেতনভাবে পর্যবেক্ষণ করতে পারি? That is an incredibly great question. It is true that there are a lot of information out there. And this question is from Shrishti. So I would say that, first of all, shut down your computer and take a walk in nature, be with people, pets that you love, take breaks, learn with your teachers, with your material. Just because a lot of information out there does not mean you have to consume it. When you do consume it, have some plan, use AI to help you summarize, use AI to challenge what AI is saying. And also, you know, one of the main things you ask, Srishti, is when you receive outside information, it can give you hypothesis. You can generate some hypothesis like, oh, I didn't know this worked like that. But then you have to confirm that hypothesis. Just because an article came out and AI summarized it as it works, yeah, it's a good idea. Doesn't mean it's a good idea. You have to still use your own auditing to see if it's a good idea. And if it works, for example, if it works, suppose even if you see it works, it might not be good for you to implement that idea this year, for example, maybe next year. So that judgment, I think to be honest, AI is changing the way we think, we operate, even our brain. There is a lot of information and we have to process it. But that doesn't mean we rush our decision based on an AI prompt. We have to understand, and we need the ability to map whether that is applicable for our life right now. Um, and human beings, we are incredibly slow to learn. We are evolving very, very slow. So just because there's a lot of information, that's why I love this question, doesn't mean all of a sudden our brain is going to become, 10 times bigger to process all that information. So take breaks from all the information. When you get the information, summarize it, and you are the judge of whether you will verify it, apply it, how you will use it, and so that your part still remains crucial. And so I think some of the papers on reasoning with AI are also good because it kind of shows us how we think. Like any papers you can read on chain of thought, Shrishti, or tree of thought, and there are other reasoning models, and you can learn about that because when you're learning, you're not just learning about AI, you're also learning about how we think. And if we can get a grip on how we think, then we can guide ourselves to think better and more strategically. So that's a great question. Since there are no more questions, thank you. I will see you next Saturday night, your time. And we've concluded 3 out of our 6 sessions. So so now it'll be every Saturday, 3 more. And I hope you're finding this useful. Have a wonderful evening.
Thank you, ma'am.
Thank you. Thank you, Miss. Thank you, Snaha. Thank you, Shrishti.
Thank you, madam.
Thank you, Clint.